Hi, welcome all to the online classes. I'm Mukesh Bhardwaj. Today, going to take a topic network analysis and theorems, network theorems. And the subject name is network analysis and synthesis. Studied in BTech Agriculture or BTech Electronics and Communication third semester. So, network analysis and theorems basically network analysis means you are going to study about the circuits, uniform circuits, and or dependent source circuit and non-dependent source circuits, and we are going to identify the voltage drop, current, and power consumed by the any resistor in the given circuits, and the basic laws to find out the current, the voltage drop are given by Ohm's law, Kirchhoff current law, and Kirchhoff voltage law. Kirchhoff current law is also known as nodal analysis or junction rule, and Kirchhoff voltage law is also known as mesh law or loop law. So these are some fundamental laws. With the help of these fundamental laws, we are going to analyze the networks, and there are certain theorems also related to these network analysis, which helps in to identify the power, voltage drop, current to any branch, through any load, through any register, or at any node or at any junction. So, network analysis and theorems or network analysis and synthesis is a very interesting subject. Uh, the basic fundamental subject of electrical engineering also, and electrical and electronics engineering. So, now methods of analysis. These are the certain methods of analysis: nodal analysis with voltage source, mesh analysis with current source, uh, nodal and mesh analysis by inspection, nodal versus mesh analysis. So here we are going to start with nodal analysis. Steps to determine nodal voltage. Nodal means junction rule or Kirchhoff current rule or law. So select a node as the reference node. First of all, we are having any sort of circuit is given, then any circuit is given, then we are just going to choose a reference node first. Then we are assigning voltage V1, V2 uh, to remaining nodes, Vn minus 1 to the remaining n minus 1 nodes. The voltages are referenced with respect to the reference node. Reference node. Apply KCL to each of n minus 1 reference node. Yes, apply KCL to each of the n minus 1 non-reference nodes. Apply KCL to each of the n minus 1 non-reference nodes. Use Ohm's law to express the branch currents in each in terms of nodal voltage. Solve the resulting simultaneous equations to obtain the unknown voltage node voltages. So this is the method for nodal analysis. Common symbols for indicating a reference node. A, B, and C. These are some common symbols for node indicating a reference node. Typical circuit for nodal analysis. These are some few examples uh, which are used to find the uh, circuits for using the nodal analysis. In a circuit A current source I1 and current source I2 is given, and the resistance R1, R2, R3 are connected, and their potential drop on V1 and V2 needs to be find out. So, for finding out the V1 and V2, that is the potential drop on resistance R1 and R3, we are going to use the nodal analysis. So, at the position number 1, if current I comes, then the junction, as you know that we designate the current at I1 and I2 and I3, because in some other branches the current is already given capital I1, capital I2, because their current sources are there, and the remaining three branches containing the resistance are not having the current nomenclature. So we indicate the I1, small I2, small I3. So I1 is equals to applying the nodal analysis on particular junction. I1 is equal to I2, capital I2 plus small I1 plus I2, small I2. So I2 plus I2 is equals to I3, I2, and the second equation is I2 plus small I2 is equals to I3. Now, as we know that current is equals to higher potential minus lower potential divided by the resistance R. Now we assume the voltage at the junction V1 is V1 and at the junction 2 is V2. Now for finding out the I2, we use the above concept V2 minus V1 upon R2. Similarly, I1, small I1 is given as V1 minus 0 upon R1. Similarly, I3 is equals to uh, V2 minus 0 upon R3, and we are going to identify the three unknowns and three variables are there. Three unknowns and three equations are there. So by the help of these two equations of I1 and I2 plus I2 is equal to I3, we are going to try to find out the solution of the current. So I1 is equals to V1 minus 0 upon R1, or I1 equals to G1V. That is the reciprocal of resistance. G1 is the reciprocal of resistance. I2 equals to V1 minus V2 upon R2 on this, or I3 is equals to V2 minus 0 upon R3, or I3 equals to V3 V2. So these equations are framed up after applying the nodal analysis. So I1 is equals to, we are going to put down the values, and by putting the values we just get some equations, and the equations are as follows. Now I1 minus I2 is equals to G1V plus G2 V1 minus I2 is equals to minus G2 V1 minus V2 plus G3 V2. So the equations further can be solved by the help of matrix, because we can uh, convert equations in the matrix form. as we know the concept of matrix and determinants. And after that, we just do the multiplication of the first matrix with the second and just equate equal to I1 minus I2 upon I2. We get the further values which we want to calculate. Now calculate the node voltage in the circuit shown. Node voltage. That is the now the values are given. Now we want to find out the voltage at point 1 or at junction 2. So first of all, we are not knowing the voltage at 1 and 2, so designate as V1 and V2. And just take a reference node which is already shown in the figure and below to the conventional symbol or below to as convention below to the circuit. Now at V1 apply the nodal at second junction and the first junction. So suppose the current I 10 ampere is coming towards this. So apply the nodal on junction 2. V2 minus V1 or V2 minus V1 upon 4, V2 minus 0 upon 6 plus 5 equals to 10. This is the equation number 1. And on applying the nodal on first junction, minus 5 plus V1 minus V2 upon 4 or V1 minus 0 upon 2 is equals to 0. So two equations are formed and two unknowns are there. Now two equations and two variables. We can easily solve the equations by putting the values from one equation to the another equation and get the result. Now see the solution. At node 1, that is V1, I1 is equals to I2 plus I3. No problem. So I1 is equals to already given, that is 5 ampere. Now our I2 can be calculated as V1 minus V2 upon 4. Now I3 can be calculated as V1 minus 0 upon 2. This is the equation number first. Now equation for node 2, as you see that I1, I4 is coming, I5 is coming and I2 is coming. So just I2 plus I4, I2 plus incoming, I2 plus I4 equals to I1 plus I5. All the currents coming to the junction is equal to all the current outgoing to the junction. Now I2, the value of I2 is equals to I2. No. Now we can write like this: 5, that is I1, is equals to V2 minus V1 upon 4 plus. So these are the two equations in matrix form. We represent these equations like this. Do the manipulations and calculations. Finally get the result. Now this is another problem. Take a circuit. Current source are given 1 ampere and 4 ampere current source are given. Now we need to find out the voltage at V1 at the junction 1 and voltage at junction 2. So apply the nodal analysis on both the junction and frame two equations and get the solution. To determine the voltage at the nodes in the figure. This is another example. The figure is shown with dependent source, that is 2Ix, and one is independent source 3 ampere are moving, and one notation related to this dependent source, that is Ix is already flow in 2 ohm. So we need to find out the voltage at junction 1, voltage at junction 2, voltage at junction 3. Apply the nodal analysis according to the current distribution. Create the equation keeping in mind the dependent voltage source and then find the equations and solve the equations. So, according to the question, we just write the equation as follows: 3 equals to I1 plus Ix, 3 ampere is equals to I1 plus Ix, and 3 equals to I1 can be written as V1 minus V3 upon 4, and Ix can also be written as V1 minus V2 upon 2. So at node 1, we had write a one equation. At node 2, Ix is equals to I2 plus I3. So Ix can be written as V1 minus V2 by 2 is equals to I2 can be written as V2 minus V3 by 8 plus I3 can be written as V2 minus 0 by 4. So this is another equation for the node second. Now at node 3, I1 plus I2 equals to 2Ix. I1 plus I2 equals to 2Ix. So V1 minus I1 is given as V1 minus V3 by 4 plus I2 is given as V2 minus V3 by 8 and equals to 2 Ix. So Ix value is already, we had calculated that Ix is given as V1 minus V2 by 2. So just put the value of Ix over here. Now the three equations are formed and three variables are there, V1, V2 and V3. So we can easily solve the three equations with three variables and get the solutions, and finally we got the values of V1, V2 and V3, that is junction voltages. Represent all the equation in the matrix form, do the calculation, multiply the matrix and equate equal to 300 and get the solution. Nodal analysis with voltage source. So in the previous slide, we had studied about the nodal analysis with current source. Now we are going to analyze the circuit when the voltage sources are there. So, case first, the voltage source is connected between non-reference node and the reference node. The voltage source is connected between a non-reference node and the reference node. So, this is the case number first. The non-reference node voltage is equal to the magnitude of voltage source and the number of unknown non-reference node is reduced by 1. Case 2, the voltage source is connected between two non-reference nodes. A generalized node, super node is formed. Next. A circuit with super node. So, if a non-reference node are encountered with a voltage source, then V2 and V3 is combinedly connect and known as super node. We consider it as a super node. Now see the concept more in detail. A supernode is formed by enclosing a dependent or independent voltage source connected between two non-reference nodes and any elements connected in parallel with it. The required two equations for regulating the two non-reference node voltages are obtained by the KCL of the supernode and the relationship of node voltage due to voltage source. So for the circuit shown, this voltage source and the voltage V1 and V2 and these nodes are considered to be a supernode. Now we just write down the equation 2 minus 7 minus I1 minus I2. Two minus 7 minus I1 minus I2. So V1 and V2 considered to be a single node or known as super node. So 2 minus 7 minus I1. What is the value of I1? I1 be given as V1 minus 0 upon 2. And I2, the value of I2 is given as V2 minus 0 by 4. V2 minus 0 by 4 equals to this. So the equation come out to be V1 minus V2 equals to minus 2. Find the node voltage in the circuit. So two voltage sources, one is dependent and one another is independent, are connected as a non-reference node within the non-reference node. Then the equation can be write down by considering the two node as a super nodes. 1 and 2 is combinedly form a super node, and 3 and 4 combinedly form a super node, a single node. And after that you just draw the put the nomenclature of equation of current and get the solution by framing the equation according to that. At supernode 1 2, so what is the equation can be written at the supernode 1 2, V3 minus V2, V3 minus V2 by 6 plus 10 equals to V1 minus V4 by 3 plus V1 minus 0 by 2. So this is called the supernode concept, and by using this supernode concept we can frame up the equations and solve the equation. At supernode 3 4, write down the equation by using this supernode 3 4, and the equation come out to be V3 minus V4 equals to 3 V1 minus V4. Now mesh analysis or loop analysis or loop law or KVL. Mesh analysis, another procedure for analyzing circuits applicable to planar circuits. A mesh is a loop which does not contain any other loop within it. A planar circuit with crossing branches. A planar circuit with crossing branches. The same circuit redrawn with no crossing branches. A non-planar circuit. This is a non-planar circuit. Steps to determine mesh currents. Assign mesh currents I1, I2, IN to the n meshes. First, you assign the mesh or the loops in a planar circuits. Then assign the currents I1, I2, IN so on to the individual mesh. Now apply the KVL to each of the n meshes. Use Ohm's law to express the voltages in terms of the mesh current. Solve the resulting and simultaneous equation to get the mesh current. A circuit with two meshes. The planar circuit is shown in front of you. In first circuit or in first, we assume that in first loop the current I1 is moving in clockwise direction, and if you are choosing the clockwise, then you need to choose all the mesh in the clockwise. It cannot be like that one is in clockwise and another is in anti-clockwise. If you assume that one is in clockwise, then all other meshes having the currents will be in the clockwise direction. The notation are different for each mesh. So for first mesh, I1 current is flowing. For second mesh, I2 current is flowing. Now apply the Ohm's law or mesh rule to get the equations. Applying KVL to each mesh. for mesh 1 minus V1 plus R1 I1 plus R3 I1 minus I2 equals to 0. Now rearranging the equation, we get V1 is equals to R1 plus R3 into I1 minus R3 into I2 equals to V1. For mesh 2, the equation can be written as R2 I2 plus V2 plus R3 I2 minus I1 equals to 0, and it can be rearranged as minus V2 equals to this. Now, put all these two equations in the form of matrix and determinants. So we arrange all these equations in the form of matrix and determinants. Then after arranging in the form of matrix and determinants, we can easily solve the matrix multiplication and just equate equals to V1 minus V2. Use for use I for a mesh current and I for a branch current. It is evident from the figure that I1 is equals to small I1 and I2 is equals to I2, small I2, I3 is equals to I1 minus I2. Now, taking one example, find the branch current I1, I2 and I3, capital I1, capital I2, capital I3, using mesh analysis. So, by observing the figure, we are analyzing that this is our planar circuit and there are two loops. So, assign loop first as I1 current, small I1 current, assign loop second as small I2 current. Now apply the Ohm's law and create the equation or the loop law equation. So after applying the equation like this, for mesh 1, minus 15 plus 5I1 plus tan I1 minus I2 plus tan equals to 0. And after rearranging the equation, we get the value 3I1 minus 2I2 equals to 1. For mesh 2, 6I2 plus 4I2 plus tan I2 minus I1 minus tan equals to 0. So I1 come out to be 2I2 minus 1. We can find I1 and I2 by substitution method or Cramer's rule. Then I1, capital I1 equals to I1, capital I2 equals to small I2, and capital I3 is equals to I1 minus I2. Now example, use mesh analysis to find the current I0 in the circuit. So in a very similar way, now the circuit is shown here is having dependent source for I0, and I0 is almost slow in the 10 ohm resistance. So it is depending on the value of I0 which is flowing in the 10 ohm resistance. So this is the circuit which is containing the dependent source. Now apply KVL to each mesh. For mesh 1, the equation is this. For mesh 2, the equation is this. And for mesh 3, you can bring out the equation as minus small I1 minus I2 plus 2I3 is equals to 0. After getting these three equations, we represent these three equations in the form of matrix. Do the matrix multiplication, put it equal to 12, 0, 0. We can calculate I1, I2 and I3 by Cramer's rule and find I0. Now the mesh analysis with current source. A circuit with current source, if a circuit is there in which a current source is there, so it's not a big deal. You can go by using the mesh rule, but certainly where there is a current source there, then the value of that loop current is automatically to be considered whatever the value is provided with the current source. Now let's see. Current source exists only in mesh 1. Voltage source exists in mesh 1. Just wait a minute. I1. So the equation for the mesh 1 can be written as tan equals to 4I1 plus 6I1 minus I2. Okay, and we know that I2 is nothing, it is 5 ampere. So I2 is equals to 5 ampere. One mesh variable is reduced. Okay, K exists between two meshes if super mesh is obtained. Now, if a current sources exist between the two nodes, then a super mesh results when two meshes have dependent current source in the common. So this is the pictorial representation for finding out the equations and do the solution. The current is not completely ignored, provides a constraint equation necessary to solve for the mesh current. A super mesh has no current of its own. Several current sources in adjacency form a bigger super mesh. For the circuit shown, find I1 to I4 using mesh analyzer. So a example is given or a circuit is given in which dependent and independent current source or voltage sources are given. Now by using the mesh analysis, we need to find out the current from I1 to I4, that is I1, I2, I3 and I4, that is the current in each mesh. What is the amount of current is flowing in each mesh. So apply the mesh law or nodal analysis and frame the equations and solve the equations. Linear equations are there, just solve the linear equations and get the values of I1 and I2 and I3. Similarly, a super mesh formed from three meshes needs three equations. One is from the super mesh and the other two equations are obtained from the two current sources. So these equations are need to be framed up and the calculation gives the results. Further, nodal analysis and mesh analysis by inspection. The analysis equations can be obtained by direct inspection. For circuits with only resistors, and independent current sources, for planar circuits with only resistors and independent voltage sources. So the circuit has two non-reference nodes and the node equations can be written as, we just represent them in the matrix form, get the solution. In general, the node voltage equations in the terms of conductance is like this, or simply Gv equals to I, where G is the conductance matrix, V is the output vector, or I is the input vector. The circuit has two non-reference nodes and the node equations were derived as. In general, the circuit has n meshes. The mesh current equations as the resistance term says, or simply can be written as Rv equals to I, where R is the resistance matrix, I is the output vector, and V is the input vector. Write down the node voltage matrix equation for the given example. So the example is given to you. We need to write the node voltage matrix. That is by using the mesh analysis. We frame the equations and then we convert or write the equations in the form of matrix equations and get the solution. So we get the circuit has four non-reference nodes, so we are just going to get the conductance. The off-diagonal terms are like this. Okay, so after analyzing the circuit, we are just going to get the following values. The input current vector I in an ampere, I1 equals to 3, I2 equals to minus 3, I3 equals to 0, I4 equals to 6 ampere. The node voltage equations are written as, so the node voltage equations are written as, now after writing down the node voltage equations in the form of matrix, now get the solution. Now write the mesh current equations for the next example. If circuit is shown, we need to write down the mesh equation. So we can easily write down the mesh equation by using the loop law or by using the Ohm's law. The input voltage vector V in volts, V1, V2, V3, V4, V5. The mesh current equations are both nodal and mesh analysis provide a systematic way of analyzing a complex network. The choice of the better method dictated by two factors. First factor, nature of particular network. The key is to select the method that results in smaller number of equations. Second factor, information required. BJT circuit models, an NPN transistor, a DC equivalent model. So this is the DC equivalent model for an NPN transistor. We can represent the NPN transistor in the DC equivalent model like this, which is helpful in finding out the currents. For the BJT circuit, if beta is equals to 150 and VB is equals to 0.7 volt, find V naught. So for finding out V naught, we use to apply the mesh analysis and just do the solution and get the equation. Use mesh analysis mode, no mesh analysis or nodal. You can either use mesh analysis or nodal analysis. So while using the nodal analysis or mesh analysis, we can represent the transistor with the DC equivalent circuit or DC equivalent model and try to find out the solutions. Now the summary, nodal analysis, the application of KCL at the non-reference nodes. A circuit has fewer node equations. So this is the main advantage while we are just doing the nodal analysis of any circuit. A circuit has fewer node equations, that is less number of equations are frame up and the solutions get faster and the time consumes less in the nodal analysis. Whereas in KVL or mesh law or mesh analysis, uh, the circuit has more number of equations. A supernode, two non-reference nodes are to be considered supernode. A super mesh, two meshes are to be considered as super mesh. So this is all about basically what we call that the before moving to the network theorems. These are the some basic laws which are used for calculating the voltage drop, current and power in each branch by using the basic laws of Ohm's and KCL, Kirchhoff current law, Kirchhoff voltage law. Now we are going to start with network theorems. So I will discuss the network theorem in the next class or in the next lecture. So the particular theorems are mesh analysis, nodal analysis we had already covered. Now we are just going to start with superposition theorem, Thevenin theorem, Norton's theorem, and there is one more, star delta transformation, star to delta, delta to star transformations are to be required. So what they are? With the help of these theorems, we can easily solve the question with less time, and the calculations are required to be very less by using the theorem. So for a specific type of circuits, specific theorem is applied. Okay. So thank you all. Thank you for today's lecture. In the next lecture, we are going to continue for network theorems. Thank you all.